Join us at The Hedge for a conversation about engineering, technology, and business. In this episode, Russ White, Tom Ammon, and Pavel Odintsov dig into FastNetMon.
Well, hello, Tom. You're in your home office today, which is cool.
Yep.
Do you have your Christmas tree up yet? That's not right if it is. Don't be doing that to me. And Pavel, how are you today?
Well, excellent.
Excellent. Good. Our second shot at running and talking about FastNetMon on the Hedge, which is good. We like open source stuff. We like projects where people can get their hands dirty and go mess with things and do what needs to be done. So last time we talked about FastNetMon, we talked about how it works and something about the history and things like that. So this time we want to talk a little bit more about use cases that people might be able to use FastNetMon for. So before we started recording in an email, you said something about outbound attack detection, which is interesting because 99.9% of the time when people think about DDoS and think about attack detection, they are thinking about inbound DDoS, right?
Yes, of course.
Right. So explain what you mean by outbound. So let's get to the use case and think about it some.
Okay, so actually when we started FastNetMon, from first time we tried to find root cause of DDoS. So what actually happened? So because after you hit by serious DDoS attack and you experience downtime, because as engineer you start looking for root cause. What happened? Why? Who started it? What parties were involved in this? What was technology of this one? And of course, all time you will end up with particular source, network or particular server which was started this DDoS attack, and then we will end up with some particular company which owns or provides service for this service. And at some point of time, we start experiencing exactly same problem, but from opposite side, because usually companies have problems with incoming DDoS attack. But if you work with for data center or hosting provider, at some point of time, you will notice that lots of outgoing traffic from your premises leave it and it doesn't look legit, because sometimes when you see like it can be a small server with WordPress, and at some point of time it starts generating few hundred megabits per second of UDP traffic, and then you will notice, okay, we have some problems in this particular segment of network, and then you will end up with to look for some tool or instrument to find out what service in your network generated this amount of traffic. And at some point of time, if you have this kind of monitoring in your network, before you receive angry emails on your abuse email, like saying, like, stop attacking my premises, stop attacking my site, your system, your monitoring system, like in this case, of course, it's FastNetMon, can notify you because some host in your network started generating enormous amount of traffic. And it's a good point to look at it. And sometimes you can apply different actions, what you are going to do in this case. You can just look on this one, or sometimes if, for example, you notice that some service started generating few millions packets per second, of course it's doable, because on modern hardware with many CPUs, modern 10G or 40G cards, it's very easy to generate really enormous amount of traffic with just single machine. It's not just DDoS, like distributed attack. It's enough to generate traffic from single machine to break almost any service on the internet.
So is the assumption then that a high volume UDP flow equals we should look at this for DDoS, or is it a high volume UDP flow means this probably is DDoS?
In some cases, yes, because usually you have quite good understanding what kind of services run in your network. Mostly it's like TCP service, which is protocol like TLS, HTTP, and it's not expected to generate lots of UDP. So in this case, you can use number of UDP packets. You can use amount of flows, because for ledger traffic, amount of flows is quite low now, because it's a ledger traffic, because it uses like it transfers lots of information between single source port and destination port. And if you start to artificially generate DDoS attack like SYN flat or like random flat, its main purpose to exhaust the resources of remote machine to generate as much as possible flows, and that's a very good sign how you can use it for monitoring purposes.
Interesting. Okay. So describe to us, so you would say that, say one of your machines has been taken over, or what specifically are you thinking of? So it's easy enough to take a single machine and to generate a lot of traffic, right?
Unfortunately,
or even to reflect off of your internal, say an internal DNS server or something like that. So when would this happen? Like, what are you thinking, or when have you seen this happen?
So from my experience, usually it happens almost all time. It starts from some maybe web software which has issues with security, like very old WordPress, outdated content management system, something like this one. And unfortunately, it's just entry point. Usually, attacker site uploads some small malware. It may be like a binary tool. It's quite rare, unfortunately. Typically, they use like Perl application, like small scripts which can generate lots of UDP traffic. And unfortunately, in most cases, configuration of Linux server allows this behavior. So you can just run this script in context of web server and start generating lots of traffic. And because of Linux security model, you actually have a right to do it. And you can generate quite serious amount of bandwidth, even with like single core from virtual machine. And unfortunately, it's quite typical. And it's not, and if you can omit case when customer decided do it with purpose, because sometimes, customers can try to do load tracing, stress testing of their own premises, like to simulate DDoS attack. Unfortunately, it's quite common, but in almost all cases, unfortunately, it's illegal. But in most cases, it's just some virus, some malware, and even more interesting, from my experiences, I saw cases when single server was taken by 2 or 3 different botnets, and they use a slightly different malware. It was like a zoo of different ways how you can attack remote machines.
Yeah, interesting. So I can remember 2 specific cases of large networks I've worked on where this would have been really helpful. One of which was there was this virus called Code Red that people may not remember, but it's been many years ago, and it infected a lot of large-scale enterprise networks, and chasing down which machines were infected, and it was causing major problems in these networks. And not only just in the fact that it was taking down servers and hosts, but it was also actually replicating itself through the corporate internet connection and across the core of the enterprise network. Wow. Having something like FastNetMon in place to see the traffic patterns and say, oh no, that shouldn't be happening that way. I should be able to see this. So this is almost an IDS-like capability, right? In that you're looking at traffic flows and saying, this is what normal is and this is what it should look like versus what you're actually seeing at this moment.
Yeah, exactly. It's very useful. But from FastNetMon, we have no focus on intrusion detection. It's not IDS or IPS software. Right. And so, for example, if you can see like 5 megabits of traffic, it's not FastNetMon's case. But if you can see something like few gigabits of UDP traffic in some very calm and quiet segment of your corporate network, where you should expect only a few printers and 2 internet phones, that's a problem. It's a case when FastNetMon comes in play and will notify you something going wrong in your network. And then you can decide what you're going to do in this case.
So I'm curious about the placement of the service. So if you're doing inbound DDoS detection and prevention, you have to build a scrub center. Sometimes you got to do all these things to make sure the traffic doesn't hit you. But if it's outgoing, then you can put it in a different place. But what's the typical placement of the service? Do you put it on the edge, the peering edge, or do you go deeper into the network?
So it actually depends on case, because, for example, if we are talking about residential services, usually they use port translation, different ways for PAT or NET. And in this case, you have to deploy FastNetMon before you implement any port translation, because in this case, you will see like internal IPs. because it doesn't make any sense to because if you map your few millions of your subscribers to few/60 networks, it will be quite complicated to find out who actually started this attack. And in this case, it will be more important to keep it as much as possible to your billing system, to your core.
Makes sense.
Okay, cool. So the other case I've actually run into where this would be really interesting was somebody had misinstalled some software backup stuff on 10,000, 20,000 desktop systems.
Wow.
And the way it worked was they had actually installed the server version of the software instead of the client version of the software on all these computers. And of course, the server version was doing subnet broadcast looking for its clients. So,
wow, I can imagine what happened.
Yeah, it actually took the network down for several weeks. It took us several weeks to figure it out.
Wow.
Something like FastNetMon would have made it a lot easier to figure out, to be able to see the traffic pattern. And now here you probably want something like this installed in 4 or 5 or 10 different places in the network, right? Which is one of the nice things about it being open source. You're not paying for licensing.
Exactly. They have no licensing. You have no limits about number of cores. You have no limits about number of instances. You literally, if you operate Linux based on FreeBSD based machines, you can install it on every machine, because we have lots of customers who run virtual VPS services. And usually they share same physical server by something about 100 on virtual private services. And actually they deploy single virtual machine with FastNetMon on every physical machine. Because of implementation of network, it's much faster and much better to detect as much as close to a virtual machine, exactly in this case on same machine, and avoid network congestion in case of really serious outgoing attacks.
Yeah. And that is a point, right, that we often think about. We don't think about when we centralize security and policy, is that it's got to be distributed, or you've got to drag the traffic. Wherever you have policy, you've either got to bring the traffic through the policy, or you've got to bring the policy to the traffic. And with this type of solution, you can actually you can do more of dragging the policy to the traffic rather than the other way around, because again, it's something you can just install on all your systems. So that's fairly interesting. So another one that we had talked about before the call was diverting traffic. So what do you mean by diverting traffic, and thinking through that use case?
So in most of the cases, our customers use FastNetMon to detect incoming DDoS to their premises, and in almost all cases, they can use last resort options, RTBH or black hole, to completely block all traffic towards their /32 prefix. And of course, it doesn't work in all cases, because what they're going to do if this IP or host shared by really big service, it's lots of your customers rely on this service. And if you don't have enough spare capacity to absorb this amount of DDoS, for example, you have 540G links, but amount of DDoS at some point of time reaches something like 200G, you have no options. You have to find companies provide service for scrubbing, and you can divert a specific network, usually it's /24, to Cloud Scribing Center, and Cloud Scribing Center will absorb all malicious traffic and deliver clean pipe to you over GRIA. And you can use FastNetMon for doing it, because FastNetMon can create BGP annonces or can call APIs for remote scribing center to remove and withdraw annonces from your own network, or create more specific annonce. For example, if you have on your network something like /16, you can announce in remote pipe for Cloud Scribing Center /24, and all traffic with small delay will be diverted to Cloud Scribing Center, and you will have a nice load. You will solve your problems with congested links, and so you will improve your service and it will work again. And in this case, FastNetMon also helps you.
Okay, so that's interesting. So again, how do you stage this, and where would you stage this? In your network, be a little more specific about is this, so when you're thinking so what you would do is you would say, for these big flows, what I'm going to do is I'm going to use FastNetMon to to find this problem, and then I'm going to redirect the traffic as needed to get to a more expensive piece of equipment to look at it? Is that the kind of thing that you're thinking about?
Yeah, so actually we have two options. You can redirect this traffic using BGP to remote scribing center in different data center across the planet. It's first case. And you also can use exactly the same protocol, BGP, for traffic diversion in your own network. And if you have any equipment for precise filtering, like, for example, from different vendors, and you can use FastNetMon as kill switch. So I noticed it's something bad for this prefix, for this host. Let's redirect all traffic and remove it from core. Because usually you may have special equipment, special deployment, like few switches or special routers, may be faster than you use in core, and remove malicious traffic out of the normal path to keep your normal traffic going, and focus on filtering in specially allocated part of your network.
Okay.
And, yeah, sure.
No, go ahead.
So in this case, if we are speaking about ways, what is the best place to deploy FastNetMon? Of course, the best place is deploy FastNetMon as much as close to your routers. So any device which can generate network telemetry in protocols like IPFix, NetFlow, SFlow, maybe switch or router. And in this case, FastNetMon should stay as much as close to a generating machine.
Okay. So this would be similar to, and potentially you could use FastNetMon for this as well, as detecting something like elephant flows or hot links in a data center fabric and being able to move stuff. Would you say that as an application you could do as well?
Actually, yes. It's quite interesting because we had quite good feedback from our customers, because as we discussed it last time, FastNetMon can export information about bandwidth for every network, for every host in your network in real time for different protocols. And actually, you can consume this information from decision making. For example, you can notice like this guy consumes lots of capacity. It's time to move this guy away from this core, move it to different switch, to different part of network, and then here you go. You can see in real time what happens. So if you decided like change priority for flows for this customer and move to different segment of your network, you will see in real time how your load reduces from single place and increases in different place, and then you can use it for traffic engineering.
So interesting. And you're primarily, of course, reliant on BGP to do this because FastNetMon is really interacting with BGP.
Yes, we really like BGP, and we offer many options how you can use BGP, because usually we rely on BGP unicast, but unfortunately BGP unicast is limited by what you can pass. It's like network address and few communities. Not in all cases it's enough. And in addition to BGP unicast, in FastNetMon we have flow spec, and flow spec is much more flexible because by default in standard of BGP flow spec, we have lots of ways how you can move traffic, you can discard this traffic, you can rate limit this traffic, you can tag traffic special way, you can set different tags for quality of service, you can tag special labels, and then you can make decision in your core network what you are going to do with this traffic. It's much more flexible.
It sounds to me, correct me if I'm wrong on this, but it sounds to me like you have all the pieces in FastNetMon. If you so were inclined, you could build your own scrub center. You could use FastNetMon to do the detection piece and do the mitigation piece using BGP. It sounds to me like it could do the whole thing, that you don't necessarily need a cloud scrubbing service if you didn't want it. Would that be correct?
Yes, exactly. But from FastNetMon, we focus it only on L3 and L4. Because if you experience like something sophisticated attack which involves attack against protocols like TCP or HTTP or TLS, unfortunately FastNetMon doesn't help in this case. But if you have lots of spare capacity, if you have really good high performance routers which can work on line rate, and you have good relations with your upstreams, which can have, and of course because upstream can help a lot because you may have different communities for traffic engineering. And of course, yes, you can build your own scrubbing center, and we have few success stories from our customers using FastNetMon for creating scrubbing centers.
Cool.
Okay, cool. Interesting. So, one other thing that I think we were talking about in the pre-show or whatever when we were talking about this recording was the ideas around fine-tuning on-premise, the filtering of on-premises equipment. But I think maybe we've already talked about that a little bit, right? In diversion, in the concept of diverting traffic as well.
Yes, sure. It's actually one of the quite interesting cases of FastNetMon because all time when you talk with engineering people and management people, it's quite different kind of conversation. Because engineering people care about ways to deploy, install, all this stuff, but management people, they think about ways to reduce money, ways to keep your budget low. And in this case, FastNetMon can be used with quite interesting case because usually almost all scribing equipment vendors, they charge you for capacity, for 10G, for 40G, and sometimes also they charge you for amount of time you for example, how long you kept your prefixes on filtering cloud, how much time you spent for how much time you triggered it for filtering for last week. And if you can use FastNetMon, it offers option for you to use scribing send as slow as you can. Because if DDoS started, redirect immediately. But when DDoS finish it, just move it back and you will be charged not for a few days of service, but for 5 hours. And also it's also quite interesting. It will help with precise filtering equipment, with scribing equipment, because you may, if you have network with 100G of total capacity, but you have filtering equipment only for 40G, you also can use FastNetMon to redirect malicious traffic and affected by attack traffic on demand. So instead of filtering everything, you can select affected prefix or affected host and redirect it to a filtering box. And in this case, you don't need license for scribing equipment for all your capacity. And sometimes budget ethics can be quite serious.
Right. So another thing that's in kind of in that same area is if I have 2 or 3 or 4 upstream providers that I'm using, I can actually use the concept of FastNetMon to figure out that I have a burst going on right now, and I need to move from my less expensive provider, move some traffic over to my more expensive provider in order to, you can do traffic diversion in that way as well. Correct? I mean, that would seem to me to be a potential use case.
Yes, it's definitely possible.
So what's the inspection engine underneath? What's it built out of?
Internally, FastNetMon use lots of different counters. Every second it calculates exponential moving average for different kinds of boundaries. We have boundary total global one for all traffic which leaves your network. We have boundaries for per network basis, as you specified in configuration. We have boundaries for host basis. And also we have drop down for different protocols, different types of traffic. So it's for TCP, for UDP, for fragmented traffic, for traffic with specific, for example, for TCP packets with specific flags. And we export all this information to all major time series database like InfluxDB, Graphite, ClickHouse, and you easily can retrieve information using GraphN or literally any interface. And you can use this information for your own system for data center management. You can consume it sometimes even for billing purposes, but you should be very careful in this case. Because FastNetMon is not billing software. Yes, of course, it can count how much traffic you downloaded and uploaded for this specific host, but main purpose of FastNetMon is still DDoS detection. Sometimes, quite different kind of software. But it can be used, but you should be just very careful. Verify it a few times, be absolutely sure that you accounted proper traffic from proper customer.
Have you seen anybody replacing other things like PM account or the other NetFlow collection type things with FastNetMon?
Sometimes, yes, but usually customers use them together because FastNetMon, it's still NetFlow collector, but by default in community version, we have no option to store traffic for long term because FastNetMon operates only in real time. We have traffic about what happens right now. We have no information about what happened a few minutes ago. But in classical software for NetFlow collection, it usually works way like store it on disk and then count something. It's like more from historical reports for like what happened a few days ago. But of course you can mix them, because if something happened now and you was on duty and you can check, oh, I see spike, I can investigate it from FastNetMon. But what happened yesterday when we received few complaints from customers? Okay, that's a good time to use different software for it.
Right.
So the different places you can run FastNetMon. Let's talk about that a little bit, because that's pretty interesting. I know it's just a Linux container, right? So it can run on basically anything that can push Linux containers.
It's actually not even Linux container.
It's not in a container yet.
It may be Linux container, but from perspective of it's just C++ binary application. And so you can use containers, you can use it on Docker, you can install it on bare metal. You can use different ways how you can deliver it in like container-based environments, like on Kubernetes. You can deploy it in cloud. You have actually no constraints, so we have no enormous like dependencies, like what you have to install, like few gigabytes of dependencies. No way. So it's quite simple application. In total size of 5 megabytes. That's all you need.
So in theory, you could run it on Sonic. You could run it on Arista directly. You could run it on EOS. You could run it on GNOS Evo directly. You could run it as a container in some of the Cisco operating systems. You can run it on anything that's OCP, right? I mean, is that all?
Exactly. Yes. And also you can run it on Raspberry Pi. Because usually it's quite interesting, but one of the main problems we experience with deployment of FastNetMon, because network companies usually not in all cases they have any Linux machines. They have routers, they have switches. That's all they care about. And here you go. For many switches, you can install like Linux container inside. And we had proof of concept with Arista, and it works really great because you can just use standard Docker container and deploy it right on switch. You don't need any special boxes. You don't need like agreement with some company to update this box, update Ubuntu inside, nothing. You just use your Arista box like for processing traffic. And in this case, you don't care about, should I care about connectivity between my switch and FastNetMon machines, like lot cable? No way, you don't need. It's just directly on your switch. It's direct access to your traffic. It's really exciting.
Yeah, well, the Raspberry Pi is pretty fascinating.
Yeah.
Tom's going out.
It's very unfair because latest Raspberry Pi is very, very powerful. But when we started our test like 2 years ago, Raspberry Pi was quite constrained in resources, but FastNetMon can run on very, very, very old Raspberry Pi. But latest one is it's lots of resources.
So Tom's going to go out and deploy a bunch of Raspberry Pis now. I can see this coming.
So I approve this idea.
So in the Raspberry Pi case, I mean, you're thinking maybe you would take a Pi and you would stick it onto a span port or something like that on a top-of-rack switch in a data center fabric or something like that. And I'm not sure it could handle the traffic speed, but okay, well, maybe not. Maybe you span port onto something so that you're looking at your eBGP connection or something like that. Is that the type of thing you're thinking about, or is that?
I don't think that we can say that we have lots of deployments of this case, but usually customers rely on S-Flow or NetFlow, and they keep BGP connection with their routers. They receive information from NetFlow from their routers, and they inject annonces using BGP when some host crosses threshold. So, in theory, yes, because we had some experiments with Espresso Bean single board computers and Macchiato Bean, because Macchiato Bean is quite exciting because it carries two 10G ports. And it has quite serious 4-core ARM CPU on site. So it's enough performance, not for 10G line rate, but it's more than enough for processing something between 3 and 4 gigabits of iMix traffic. It's not about line rate, but it's enough. But size of this board is really small. And in this case, you can use span ports, and of course you will be constrained, but you can use some tricks from network engineer world. You can use like samplet span and sample traffic from like 100G, scale from 1 to 1,000. It's like 4. It's not so much, and you can use it and consume it from SBC board.
Yeah, very interesting. All right, well, very good. So, Tom, you have any other use cases or questions about FastNetMon?
No, that all sounds really interesting. And I have right here, since you mentioned it.
Oh, really?
There it is.
Cool.
Sits on my desk waiting. It's been waiting for FastNetMon. That's why it's been sitting here.
You can start installing it right now, because if you use you use fresh Debian, you can install it just using apt install FastNetMon. That's all you need. Because it have complete support for ARM64. It works really well.
Wow. So now Tom really is going out and deploying these on Raspberry Pi tomorrow. In fact, because it's on a Raspberry Pi, you could install this on your home network and have a sense of what your IoT devices are sending out and stuff like this. It might actually be an easier way to see what's going on than many of the other ways that have been posited by people doing all sorts of strange things in their networks. So it's really cool. Well, Pavel, thank you. So where do people get it? Again, just so that people know where to get FastNetMon if they're looking for it.
So best way to download FastNetMon is GitHub. So just open GitHub, fill FastNetMon in search string, and you will find out not only FastNetMon, it will be, of course, on top of your page, but you will see lots of contribution from community, like different integration like with monitoring solutions, alerting solutions like PagerDuty, Slack, all this stuff. And you can find different cases about packaging for different platforms like Docker, VMware, and you, of course, will find out something interesting for you. If you just started with FastNetMon, you can see more, maybe your problem already solved and you have integration with your favorite vendor from FastNetMon. It's out of the box.
All right. Awesome. Thanks. And Pavel, do you blog or anything else other than through FastNetMon?
No, unfortunately.
No, it's fine. It's fine. It's cool. And Tom, you're on Twitter, I know, and not blogging yet. I haven't seen any blogs yet. It's okay. We'll keep working on it. So it's just at Tom Ammon, right?
Yeah, at Tom Ammon. Yep.
Great. Awesome. And I'm Russ White. You can always find me at rule11.tech. And thanks for joining us on this episode of The Hedge.
Thank you for joining us. You can find The Hedge at rule11.tech.